So far, we've been using the definition of convergence of a sequence to determine whether sequences converge or diverge. Now we're going to start exploring properties that limits have once we know they exist. Once we know we have convergent sequences, what are some things that we can do with them? So the first question for us is going to be this. Can a sequence have more than one limit? So this is actually not this is not precluded by the definition of convergence. Convergence just says that there is a limit that you can get close to, but it doesn't say there can't be more than one. So this is the idea that we're going to explore right here. All right. So here's the first exercise that I will run through with you, and I want you to basically use this idea that we're going to employ to prove a more general statement. All right, so the exercise is to show a sequence AN cannot converge to both 0 and 10. So the idea here is I have two specific proposed limits for the sequence. In the more general version, you just want these to be arbitrary, so we'd represent them by symbols. But let's talk about how we might be able to do this. So I'll do a bit of scratch work to start. All right, so what's my scratch work? So if this is true, right? So if if AN converges to 0 and 10, then let's just talk about the definition of convergence. So for any epsilon greater than 0, there exist, I'll call them n1 and n2. So the capital N's here are different for 0 and 10, potentially. I don't know exactly how it works out, but for 0, I should be able to find a capital N. I'm calling it capital N1. For 10, I should be able to find a capital N. I'm calling it capital N2. So there should exist capital N1, capital N2, such that if N is greater than N1, then AN is within epsilon of 0. And if N is greater than N2, then AN is within epsilon of 10. All right. So I'm aiming for a contradiction here, right? So I assumed here that AN converged to both 0 and 10, but we're trying to show that this can't happen. So I want something along the lines of this diagram here. So this is the number line. So 0 is over here. And let's say 10 is over here. And what I want is the following. So let's say I sort of wrap a little interval going out epsilon on either side of the two limits. So that's epsilon there, and then this is also epsilon here. So what's happening, what this diagram is trying to show is the following. If little n is greater than n1 and n2, then AN has to appear in both of these intervals I've drawn, right, around 0 and around 10, but that's not possible. It can't be in this epsilon neighborhood around 0 and also in this epsilon neighborhood around 10. Then AN must be in both of these intervals, but that's not possible. Okay, so that's the contradiction we're trying to arrive at. So what can we say here? Well, the little neighborhoods, these intervals, they can't overlap. So in order to make sure they don't overlap, right? If they overlapped, then it would be possible for AN to be inside of both. To make sure they don't overlap, epsilon can't be bigger than 5. So the intervals don't overlap. We need epsilon no larger than 5. And the thing here is that we are assuming the sequence converges. Once we had that, we can sort of pick epsilon to suit our needs. So once we know we have convergence, we can pick an epsilon that is going to do what we want. Right, so that's the basic idea, is that it's not possible because you need a certain amount of closeness at some point to both of these limits, and you can't be, at one point you will be too close to one limit to be close enough to the other one. That's the rough idea of what we're saying here. So how would this proof go? Okay, so here's our proof. Oops. So let's suppose an converges to 0 and 10. Okay, so I'm going to let epsilon be 5. So again, actually any positive number that's smaller than 5 would work. So if you picked 1, 2, 3, pi, like all of this would still work out. In any case, if epsilon is equal to 5, then we know, because an converges, we know there exist these numbers, capital N1 and capital N2, such that, n greater than N1 implies that an is within 5 of 0, and little n greater than capital N2 implies an is within 5 of 10. Okay, and remember I was saying, okay, so I want to be within 5 of both of these. That's what we want to force to happen. So that's certainly possible. Just let little n be bigger than both n1 and n2. Right, that certainly can happen at some point, as long as little n is greater than the larger of n1 and n2, then we have that. So if n is greater than n1 and n is greater than n2, and this can certainly occur, we have that an minus 0 is less than 5. So the absolute value being less than 5 means that that expression, right, an minus 0, has to be between -5 and 5. So this is telling us that minus 5 is less than an is less than 5. Okay, and we have an minus 10 in absolute value is less than 5. So what does this imply? This means that minus 5 is less than an minus 10, which is less than 5. Now add 10 to all the parts. So we get 5 is less than an is less than 15. All right, so this is the problem. There are two intervals that do not overlap, that an is supposed to be in both at this point. So that's not possible. Now we have that an is less than 5 and an is greater than 5. A contradiction. Okay, so it's not possible for an to converge to both 0 and 10. All right, so I would like you to generalize this idea. So I use 0 and 10 here, but there's nothing special about those numbers. As long as you aim for a contradiction and assume that you have two different limits for the sequence, we should be able to do something along these lines. So for exercise 2 here, which is one I would like you to do, and we can discuss, prove that if an converges, its limit is unique. Okay, Okay, so if a sequence converges, there is exactly one limit. Okay, so again, similar idea here. Go for a contradiction. Look at what we've done. Look at the scratch work that we were talking about. Ask about what I was doing with exercise 1, and try to use that to prove in general that a sequence can only have one limit, if it has a limit at all.